Good morning, good afternoon, and good evening, everyone. We may just wait another minute or two to allow folks to join, but we'll be getting started very soon. So there is a chat box, so feel free to post your questions, and we will aggregate them, and I'll make sure to you can ask them either in the chat box or in the ask a question box. And at the end, we will be sharing the presentation so that you can follow along at the end with any links or any follow-ups to the socials. So we'll go ahead and get started. Welcome to another session of the Moonbuilders Workshop, today featuring Chirag from Bioconomy. If this is your first Moonbuilders Workshop, we're so glad that you joined us here today, and we hope that you consider joining us for a future one. Kathy organizes these fantastic workshops, and we have one about once per month. Many of you are probably already familiar with Moonbeam, but if you're not, Moonbeam is an Ethereum-compatible smart contract platform on Polkadot, and our focus is on providing the most seamless development experience for Ethereum smart contract developers, and also to provide the best on-ramp to the Polkadot ecosystem. So Moonbeam is the name of our Polkadot deployment, which is not yet live, and Moonriver is the name of our Kusama deployment, which is live. My name is Kevin Nielsen, and I'm a developer relations engineer working on Moonbeam. And today I have the distinct pleasure of introducing Chirag to you. Chirag is a smart contract and blockchain developer from Bioconomy. And prior to joining Bioconomy, he worked as a technical product manager and a freelance developer working in Web3 and Web2 fintech technology space with Citibank. Chirag holds a bachelor's degree in electrical engineering and a master's degree in power electronics from IIT, the Indian Institute of Technology. Chirag will certainly tell you more about Bioconomy, but to briefly introduce it, Bioconomy is the next generation multi-chain relayer protocol that solves a number of problems that Web3 users face. Allow me to set the stage and provide an example. Imagine you're the first-time user of a dApp. Your friend just told you about a new NFT release happening in 20 minutes. You're eager to participate. The FOMO is real. Your friend helps set you up with a wallet in MetaMask. However, you don't have any tokens and you're not sure exactly how you're going to be able to pay for gas for this mint. Bioconomy solves all of this, and Chirag will tell you more about how it works today. Bioconomy is already 100% live on Moonriver, so you can start building with it today. With that, I'm going to go ahead and turn it over to Chirag.
Yep. Hi, everyone. Thanks, Kevin, for the introduction. And thank you, Kathy and Kevin, for having me here today. So today we are going to talk about some of the aspects of, the usability in Web3, mostly focusing on the gasless transactions and ending up with some other ideas to sort of reducing the friction in this space. So let me just go straight ahead and, begin. So this is the basically I wanted to just give in context on current state of Ethereum and DeFi, like all the side chains, different layer ones. So there is lot of there is about almost 200 billion value locked in DeFi protocols, and these are some of the numbers of the daily transactions, just to give in context of how much activity and how much liquidity is out there versus when we actually observe the user adoption and in terms of the number of addresses interacting with the Ethereum protocols, or be it on any other layer 2 chain. And just to give some more context versus the Web2 space, so there are some applications listed here. I'm going to talk more about usability, but before that, I just wanted to generally talk about the hurdles with blockchain. So ever since 2017, we had this first crypto boom, and at the time, the community recognized that okay, we have this problem of scalability with the crypto kitties and the Ethereum network being congested, and there has been a lot of focus on the scalability solutions on the blockchain. So then a lot of layer 2s came up, and now we see faster transaction speeds. So this is one aspect of it. Apart from that, another problem is interoperability, which is there will be so many siloed blockchains, and each having their own audience and the applications on top of them. But then it introduces a problem of user interacting with like several tabs which may be on like different blockchains. So how do you like sort of like move the liquidity, and what are the other challenges that, or the steps that I every time have to do before like switching from like one network to another, or one tab to another tab. So this is also getting better, like with the cross chain bridges and the contract to contract calls from one chain to another. And this is where like we also come in, like in terms of like thinking of like this multi-chain future. And the last thing is usability, where I'm going to talk about like case by case, more on the usability side of things. But in generally, there is like a lot of hurdles when a new user comes in, or even the crypto savvy user is interacting with the app. So basically, in order to pay fees, like in order to write something to the chain, I need to pay the gas fees, which is in the native token of the network I'm interacting with. So it can be like Ethereum, BNB, Mover, so these kind of like native currencies. I'll be paying the gas fees in. So as when you think about user adoption, like the users which are basically using your app, how do they just gain that currency just in order to like pay for the fees? Because there is this whole round trip, and I'll try to like explain this more through some of the like use cases. Another challenge is you have to like rely on the gas oracles, and like sometimes there are gas wars happening because the network is getting like more overwhelmed with the transactions. And as a user, I need to like have more knowledge about the gas prices. How do they behave dynamically? How do I like sort of like change the RPC and the network and in my wallet? And then I need to like monitor my transaction, and still you can't be sure that whether it will be confirmed or not. So there's a problem of like pending and stuck transactions, and it happens on every chain. Apart from that, the obvious creating a wallet, like the Kevin talked about the problem or story where like a new user, like a friend of mine is creating a wallet for me, and then he's trying to like sort of explain that, okay, this is your private key, you need to remember, if you lose it, then you lose all of your money. So all of these complex steps are there for an extremely new user, or just like a new NFT artist which doesn't care about how blockchain works, right? uh, so these are the challenges, like even if you're like UI or UX is sexy on the web 2 level, but like there are these are underlying issues. This is just one of the illustration to show like in order to interact with the web3 dapps, you need to like basically stop at like every point and like pay for the gas and like go through that whole journey. So this is like one more of an infographic in that sense. Other than this, I just wanted to talk a bit more about like what is the difference when you have the web 2 stack versus when you are creating a new web 3 stack. So there are like a lot of mature tools and the composability solutions that you can actually use. And for example, there is Transact to like provide you fiat on ramp solutions. So when you design architecture for a web 3 dApp, and it if you need to like provide the experience of a web 2 applications, what are the challenges, or like how do you expand the markets basically to like create these sort of an application?
And one
And
thing just to point out is that for people who are new to crypto, right, getting from fiat to crypto could take weeks, right? Especially in the United States, because you'd have to pass like a know your customer, and you'd have to connect a bank account, and that whole process can take a very, very long time. So just getting like a wallet started, right, with a little bit of trying to get gas can be like a very long process.
right. So I was just discussing one case with a friend. So let's say, you participated in some DeFi hackathon. You're a Web2 developer, and you did some work for a protocol or a client. And let's say your employer or this person pays you in USDT or in their native tokens. Now you want to move this USDT to your Binance wallet, let's say, and even to like move this, you need ETH for this, right? Like let's say we're talking about Ethereum blockchain here. So in order to gain this ETH, I need to like register on an exchange, do the KYC, like the process you mentioned, Kevin, right? Like it can take about like days, and then I get that ETH on that particular exchange. Then I'm going to like transfer that ETH to my wallet here where I received USDT, and then I can initiate finally a transaction to spend that USDT to someone else. So instead of this whole cycle, if what if like someone was to sponsor your gas fees? So we are talking about the account abstraction here, like where the payer of the gas fees is different than the actor of doing that particular transactions, if that makes sense. So I'll be talking more about this when we like actually go in the depth of the relay infrastructure, and we'll also be doing like one or two demos to showcase. uh, yeah, so the next step is like what should be the goals when you are creating a dApp and you want to solve these problems that we just talked about. So and there are benefits, like how do you onboard the next billion who doesn't know about like this complex Web3 world. So first major step is like to focus on like to capture these users, and how they can onboard it with your dApp by like doing this user onboarding process, or like bearing the cost of like sponsoring, let's say, X percentage of the transactions. And yeah, I mean, another problem like is when you want to actually move your assets from, let's say, one chain to another. You want to go and interact with a dApp which is on some L2, and it's a gaming NFT dApp, let's say, and you need to like move some liquidity from like one chain to another. And usually the native bridges like it takes about like 15 minutes to 20 minutes to like go in, and when you need to come out it can take for about like half an hour to 7 days. So these are the challenges like on the interoperability or the like liquidity migration side as well. And how do you provide like cross-chain integrations and more sort of like value transfers which is like accessible for even not crypto native user. And another thing which I like emphasize on is how do you do the user driven developments. First, like analyzing, okay, these are the challenges, some users are not able to pay with crypto, and how do you provide like on ramps. So this is just an example of handling your webflow according to this in your TApps. And yeah, the next step is like now I'm going to introduce about like Moon River and then Bioeconomy. So how do we like relate, and how does like each project works. So building on Moon River is like Kevin said in the beginning. So it's like easiest or on ramp or your opportunity to like tap into the liquidity in Kusama ecosystem, which will be like the next stage will be like tap into the liquidity of Polkadot ecosystem. So the journey is like very easier for an Ethereum. Let's say you are already an Ethereum developer and you have some your smart contracts in your dApp, or let's say you are developing new contracts. So you can't even tell the difference whether you are like developing on Ethereum or Moonbeam. So the first step would be, let's say you deployed a contract or you already have a contract on Ethereum. You first like if you want to test it out, you go to Moonbase Alpha, and then you want to like sort of move to the next step. So that's where Moon River comes in to give you like in production like Canary environment, which is on the Kusama ecosystem. And apart from that, there are a lot of other benefits, like you get the shared security of like other parachains in the whole Kusama ecosystem or the Polkadot ecosystem later on. And interesting use cases can come up where you are like sort of like moving some of your workload to another parachain in that ecosystem, where let's say if I'm doing an NFT drop and I want to to like distribute some passes like to the users who will be able to mint that NFT, so that there are no like gas auction wars. So I could do it potentially on like integrating with another chain in this ecosystem. So this is like major upside point which like appears or very appealing to me. And apart from that, like the tool sets as a Ethereum developer, which whatever you are used to, so it's like the easiest way. Like I can use the Hardhead, Truffle, Remix, and even like for the JSON RPC calls, I don't have to like learn and go to the docs of like another chain and like actually understand like, okay, what are these calls and how do they change in the context of a particular chain. So it's just like this EVM environment and all the familiar tools you can actually see in this ecosystem. Moving on to Bioeconomy. So Bioeconomy is basically, so we also share the vision of a multi-chain infrastructure, and being able to like serve the users on like different blockchains. So basically you can think of this as a transaction layer where dapps can integrate and make the user journey easier for their end users. So we are like trying to make the web3 space easier for everyone. And here are like some of the features for Bicno. So first aspect is the gasless transactions, which we are going to talk more about in detail and go through the demo as well. Another is like there are some other benefits as well. So for example, the USDT use case which I talked about. So what if you are able to let's say I want to migrate 1,000 USDT and I want to pay fees, let's say 20 or 25 USDT as a gas fee. So when you integrate Bioeconomy, it allows you to do that on your dApp. So this is like expanding the services on the like the usability side of your dApp. And also there are like some other benefits. So for example, if user wants to like interact with a BSC dApp or Moonriver dApp, or if I'm like moving from Moonbase Alpha to Moonriver, and I need to like constantly change the RPC if I'm on a native dApp, right? But this is what like we call blockchain agnostic, where in that case we sort of like abstract the wallet provider versus the network provider concept, where like you can still sign the messages and without changing your RPC you can basically interact with like all of these tabs, just like as if you are logged in into any web2 application. uh, so these are the benefits, and like I'll jump more into how the relay infrastructure actually works. Yeah.
So that was really cool. I just wanted to
Mhm.
ask a follow up. So there's no need to manually change the RPC or to change your MetaMask to a different to connect to a different network. Why isn't that necessary?
Just like I was talking about, the notion of a wallet provider versus, the actual network provider, which you sort of like, create with your RPC URL and then your provider object. So that provider is specific to your network. So Bioeconomy allows you to, import an SDK where you can actually say that, okay, this is my wallet provider, which is going to just, sign the user messages. And this is my network provider, which is going to interact with the smart contracts on the network which my app is on. Right. So and because like since the user is not paying the gas, they are just signing a message. So it's just plain cryptography where you just need like a window.ethereum object. It can be any other chain, right? Like whichever network you are connected to on your browser MetaMask. And behind the hood, like you are just getting the signature from this connected provider, and behind the hood you are like sending the transactions from a different provider from your client side code. So if that makes sense.
That's a huge benefit. And can you speak to the how the relayers kind of monitor transaction status, and how do they decide? We're monitoring a pending transaction, but we need to speed it up. How do they make that decision?
Right, right. So basically, yeah, these are the features. So first, starting off with the notion of the gas price, or like how do we decide an optimum gas price. So for this, like we are using some of the gas oracles based depending on like each network, or see the historical transactions in the last couple of blocks, and starting off the transaction with an optimum gas price. And for EIP 1559 supported networks, like you sort of like provide the base fee and the priority fee. So this is done like to sort of like start with an optimum gas price, and then we sort of like monitor all of these transactions by checking the confirmation status of these. And let's say if I am on X network and the block time for this network is, let's say, 2 seconds, so we wait for like 50 blocks, so that is about like 100 seconds. And there can be like some reasons where like initial gas price that you provided was low, and it has hasn't like come down to that value yet, then that transaction is still in pending state, right? Or sometimes like your node provider is not efficient and it is like dropping the transactions that you are sending. So based on these time for each network, we get to know that, okay, now we need to send this transaction for resubmission. So there are like couple of retries that happen this way, and for every retry, you send the transaction from this relay infra with the same norms, but with like a slightly higher bumped up gas price. So this is part of the configuration for all the networks. And yeah, these are like sort of like the benefits for like we talked about blockchain agnostic, and we talked about like bumping up the gas price and retrying the transactions. So as far as like you are concerned as a dApp or an end user, you just need to call the API once, or you just need to like interact and give your signature once. And behind the scene, the whole relay infrastructure takes care of like tracking your transaction this way. And you just need like you just get the initial hash. So I'll show that more in the dev tool section of the demo that we'll do.
It's such a better experience than trying to go and increase the gas price and then check a page and check gas now and check Etherscan gas tracker and all that.
Yeah, it gets frustrating for the users all the time. Like, where is my transaction? What happened? Yeah. So moving on. So these are so without bioeconomy, this is what we are just like talking about, right? Like you need to sort of create this infrastructure. If you're a dApp and if you're an end user, you need to learn of like the complexities of the Web3 world, and then there are like a lot of other things, MEV, like front running. You need to like take care about all of these things. So these can be like bundled up in the solutions. And when you're using this, so we are sort of like providing SDK and the APIs to as a plug and play solutions, which you can like integrate with your dApp on Moonriver. And it's like as easy as like modifying or writing 3 extra lines of code in your dApp. So basically like you import Bioeconomy from as an SDK, or you can create an API endpoint, and you can just like keep on calling this API from your backend to process a meta transaction, and it's like super easy and super quick. So yeah, this is just more of an illustration of what I just talked about, like what are the benefits in terms of like the transactions and paying the gas fees, monitoring and like the speed of your transactions. Also like how do you optimize gas in some cases. So this is also like covered in like when you use like some of the products. Cool. So now I think we will just move on to the sort of the demo and like getting in depth with the meta transactions. So this is how a typical meta transaction works on a very high level. So basically the idea is like the person who wants to interact or let's say buy an NFT. They are not paying the gas fee. So we are talking about account abstraction here, where external third party pays for the gas on your behalf, and you are just meant to like make your identity through your signatures, right? So user just like signs and sends a request, so we are calling them a transaction signer, and this is a Bioeconomy relayer which will like forward these transactions to your contract, but it will also do like some of the stuff like within your contract by making it meta transaction compliant. So we will just like I think cover that in the next 1 or 2 slides. So this is the general idea. Like I, as a user, I have just given my signature, and this relayer knows that okay, there's a signature. I need to verify this signature against this user address. So signature verification happens here, and since you have like replaced message.sender in your contract with like a helper function, which sort of like responsible for identifying okay, this transaction is coming from a relayer or this transaction is coming from a user. So this helper knows that, and then it like sort of performs the the actual call on your recipient contract. So this is the idea, and like the entities on a very simplified architecture like compared to like other gasless solutions out there. And yeah,
just one thing before you move on to the next one, can you remind us what a meta transaction is and how it's different from a normal transaction that a user sends?
Right. So let me go back here. So basically, the idea is when you send a meta transaction, and when you see that transactions on the block explorer, usually when I send a transaction from MetaMask by paying the gas fees, in the explorer, in the contract call, like if you check on block scout, the from address will be my address, right, and the to will be the contract address. So in case of meta transaction, from can be like any party or a relayer, who is sponsoring for your transactions, and still like you are able to do the state changes as intended, as if like I am paying the gas fees. So this is the concept of meta transaction, or like sponsoring transactions on someone's behalf. So this is the idea, and I think I'll cover this more on the contract level, which will be the first step here. Like how do you actually modify your contracts to integrate by economy. Cool. So for to integrate Bioeconomy, I think the good step to start with is with the Bioeconomy docs, where you will see the first one about like enabling the gasless transaction in your like Moonbase Alpha or Moonriver tabs, and there are like several approaches to do the meta transaction. So the two approaches I'm going to talk about like is the custom implementation, and another is like EIP 2771 standard, which is like more standardized way of doing a meta transaction, where you have like a trusted forwarder contract which just like verifies your signature and sort of like transfer the calls to your recipient contract. But on the very high level, there are like only three steps. First, you need to like make smart contract changes to make your contract meta transaction compliant. Just the stuff that we just talked about here, like how does contract know that, right, that if it is coming from a relayer or it is coming from an end user. So this is the first step, and these steps are only one time. So once you make these changes, and the methods, let's say want to make mint NFT or a transfer NFT method gasless, or like transfer ERC20 method gasless. So for these methods, I'll check like wherever I have message.center dependency, I'll just replace that with an helper which we just talked about. So once you are done with this step, you can like sort of like redeploy your contract with these features, and it is one time. And another thing is like you can access your dashboard and create like a new dApp based on like the network that you are interested in. So we are supporting like a lot of different main nets and test nets as well. So these are the actually steps to like what I mean by registering artifacts is like, let's say I have this smart contract with this address. I want to have some methods gasless into it. So I'll be actually registering this contract here, and once I register the contract, I need to like specify, okay, these are the methods I want gasless. These are the methods like basically I want to sponsor transactions for the users. So it's like specifying this artifact so that like when you send out a transaction through Bioeconomy, the backend knows that okay, this is the call that I need to send it to the relay. And the third and final step is the making some changes in your dApp's code, which interacts with the Web3, the way like you call your smart contracts and the provider you use. So it goes up to like maybe like 3 to 5 lines of code at max. So I'll like cover these steps in detail, or maybe like based on the questions once like we go ahead with the demo. Yeah. So just like I explained, so this is like the first step where like let's say you have already modified your contract, and in order to like make your contracts meta transaction compliant, like I mentioned, you need to inherit from a certain base contract. So this is a base contract here which provides the meta transaction capability in your contract. So this contract is typically used for a custom approach, and there is another contract which you can use as a base to use the EIP 277 approach. And only the only difference between them is let me actually try to cool. So yeah, before we go for the demo, this is how like a typical transaction works for a custom approach. And why do we call it custom is like you can have a control in the way like you want to show up your signature on when a user signs a request. And this is like, more of an old or a custom standard where like some of the tokens added this. So for example, like DAI or USDC have this permit feature where like user signs signature, and then you sort of like divide the signature ECD DSS signature into components, and this signature is like part of your parameters in the method, right? So for example, if I go back here, let's check. Yeah, so for example, for the permit function, so this is how it looks like. So permit is essentially like, you are approving by a signature. So this can like, be treated as a meta transaction. So in such cases where, in the contracts where you have a method like this, which, takes the user signature as a parameter, you can register them as a custom approach in the contract. And you need to actually, specify the type hash here. Like, okay, these are the parameters which I want to show to the user when they sign a request. So more on this will come on the, the when we actually get to the demo. But this is the idea, like I can have more control over like the EIP 712 types of signature in this case. So in this contract as well, I have this function. So for making, all the methods that you want to make gasless, you sort of take the user signature and provide the function signature. So this is nothing but the method that I want to call, and what is the data, to be appended to this method. So this is how like this method can be like registered when you make your contract, with like base contract is this contract. So let me just get started with the demo, and I think we'll come back to this contract, like how it is deployed. And cool. So for example, I have created one pull request as a workshop where let's say if this was my contract, and how do I add the meta transaction features to that contract. So for this, I have inherited from base relay recipient. You can also use OpenZeppelin's ERC2771 context. So basically, what these contracts do is give you the feature to sort of have this underscore message sender. So if you notice, I replace mst.sender with this particular helper. And what it does is, let me actually quickly open up. It's not the correct line. So this contract looks like this, and it falls under the EIP 2771 approach, where you can specify that, okay, this is my trusted forwarder, which is a contract from which will be like forwarding your transaction, and you can like introduce this helper. So what it does is, like, if the transaction is being passed on through a relayer, then what relayer does is, like I said, you abstract away the address and the signature, or the the address who is like signing the message. So it appends the user address at the end of the call data. So this method is actually decoding the user address from the appended extra bytes in your call data, and then it just sort of like returns the message sender based on like if it is coming from a relay, or if a user is calling it. So once you like make these changes in your contract, and let's say if I have a method which is uh, dependent on a message.sender. So once I call this method and I want to make it gasless, your contract knows that, okay, this is a meta transaction and I want to process this way. Also more on like the two different approaches. So like this is the general idea of a meta transaction, where a relayer initiates the transaction and pays for your gas, and this here is your recipient contract. So to illustrate that, I have very simple test contract deployed here. So in case of custom, I'm inheriting from this contract, which is called EIP 712 meta transaction, which we just saw here. So this allows you to process EIP 712 type of signature. What I mean by this is, like, let's say when you sign a message, sometimes if you are using ETH's old personal sign, it just shows you a random hex message.
Hmm.
So your user can be, intimidated by this kind of like a random message what I'm
You have
signing.
no idea what you're signing. Yeah, it could be
Yeah.
anything.
Exactly, yeah. So EAP 712 signatures are preferred over that in this case, where you can actually, specify like your own type hash that, okay, I want to show that, okay, this is a nonce, this is my address, and this is the actual data that I'm signing. But you can even split this function signature into various parameters. So let's say if I'm doing a uh, DX trade on 0x, so you can like sort of see who is the maker, who is the taker, what is the maker fee, who is the taker fee. So you can actually be confident that, okay, this is what I'm signing, and you can actually cross check that with the smart contract which is published. So these are the benefits of custom. And if you notice, in this case, when we are inheriting from this contract, so it basically, this is my recipient, right? And it introduces the features of verifying the signature and nonces in this contract itself. So for example, when I call this method, and when I pass on the user signature, it will actually call this verify method, which will like do the job of like actually checking if your signer and the signature, if they are matching or not, and if they do not match, it will throw an error. So this is one protection level to actually sort of like verifying the signature, and all the meta transaction contracts needs to like go through this. And another important aspect is like which we call as replay protection. For that, like you sort of like you actually like maintain the nonces, and you increase the nonce with like every request. So this prevents, like, let's say I passed on a meta transaction, I have given my signature. So how do you prevent someone intercepting your signature and sending it to like another contract? So these are the two aspects like we need to check in the contract to make it meta transaction compliant. And in the custom approach, like I said, like and showed here, it is done within your contract itself. Versus an EIP 2771 approach. So you can actually go through this EIP and read more about this, and it is like a new standard which is applied on like all the blockchains which you can like when you are doing meta transactions. So in this case, what would happen is like relayer will still initiate the transaction. So there's an EOA relayer. So this guy pays for your gas, and then they forward your call to the trusted forwarder. And for this also, I can share the implementation here. So basically, this repo is open source to contribute, and all of the forwarder contracts are here. So here as well, if you notice some similarities where like if a relayer calls this method, the signature will be verified here, and like the nonces will be updated. And apart from that, the third step is like it illustrates here. So once you do like all of these jobs, so this contract's job is on to only do these two things, and then it's just like forwards the request to your contract. So there is this intermediate contract in this standard, but the whole philosophy is the same basically. So this is the third line of actually forwarding the transaction. And if you notice, when we are forwarding this transaction, we are appending the user address, which is like this request format. And you can pretty much define your own request formats here. So I have this like forward request type where user will be signing this message that, okay, who am I, where which contract I want to interact with. The token address is something like, let's say if I'm allowing to pay in any of the supported fee tokens, then this is also possible. What is the maximum gas that I'm committing to this transaction? So these are the like attributes you can specify with a particular request. And like we were going through this, like it basically appends your user address here. So when you have you know inherited this base contract in your contract, this guy knows that, okay, this data is appended by the relayer, and this is how like the whole system from this end to this end connects with each other. And the point of registering the artifacts on the dashboard is like we have an SDK which will basically, so let me just go ahead and just interact with the dashboard. So I have like created some dApps here on various networks. So you have to come to the Bioeconomy dashboard. So this is the second step we are talking about from this flow. Like once we go through the the smart contract changes, and this is the second step where like you sort of like actually register your artifacts. So you have to come here, and maybe I can create a new tab. So I can call it like demo multi-chain. You can give any name to your tab, and let's say I want to create on Moon River mainnet. And so once you have like access to your dashboard, this dApp is created. And if you notice, like you get like several options to see your transaction stats, the configuration that you want to do, like to whitelist some users. And these are like some meta transaction limits, so that no one can, like, if let's say as a developer or as a dApp, if I'm sponsoring the transactions, how do you prevent some of the Sybil attacks, right? Because you have made it free for your users. So in that case, you can also like specify what is the API limit, what is the user limit, and what is the maximum dApp limit. And this can also be changed in like number of meta transactions that I'm allowing at a dApp level or at a user level. So this sort of like prevents like some of these concerns in terms of like sponsoring. And here you get your API key. So when we actually like go through the code, basically this is the way you change your current provider. So this comes in a third step, where like how do I actually like change the client side code. So here I'm just like, I have an ethers provider which is connected from this http URL of Moonriver RPC. And the idea is like you sort of like wrap your provider and create this wrap Bioeconomy wrap provider, and use it for all of your artifacts later on. So for example, when I'm creating a contract here, I'm specifying the Bioeconomy's provider or a signer here. So this way, when you interact or like send a transaction to this contract object, the and it already knows like the API key, and it already knows like the artifacts that I've registered here. So for example, let me open up some tab where I already registered this contract, right? Like after doing the changes which we just talked about here. Uh, so I can register a new contract in a dApp, and I can specify the approach, based on the. So this, like all of this is like can be referred from the docs or the today's demo. Uh,
And if
so
you're if you're an application, you're sponsoring, right? There's a concept of a gas tank, right? So
yeah.
if somebody wants to provide, one Moon River to be used for the application, then they'll deposit that with you, and you will,
Right.
it'll be used, right?
Correct. Yeah. So this is the question like we get asked on, like how do I sponsor, or how do I deposit? Let's say I want to, like you said, like I want to sponsor up to one amount of mover. So this is like an initial pre-deposit that will be made to a smart contract, which will basically transfer your deposit to the main account, which will be responsible for funding the relayer nodes. So there are like X amount of relayer nodes, and when you send a transaction, these nodes know that okay, I need to process this meta transaction. So these will be like using the deposits that you have made. And in terms of like, if you want to see like how these deposits are being used, you can actually see in this stats that okay, so far I have paid, I have sponsored this amount of transaction fee, and I can actually see that okay, how much balance I have left with, like from the deposit I have made. uh, yeah, so coming back to like how once I register the contract, I can register new APIs. So APIs is a way to tell my dApp that okay, these are the methods on this contract that I want to make gasless. In case of custom, you always register this method because it gives you the function signature as well. Like you will be specifying the function signature as part of that call. Uh, and for the EIP 2771, I could be like actually registering the method name. So I have more control over there. And the benefits are like even on the client code side of things, when we like move on to that demo, you can actually see that the lines of code are even less. So coming back to this, as I was saying, like once you have created a contract object with the Bioeconomy's SDK, which like knows based on your API key what are the these registrations are out there. So when you like hit a transaction to this contract, what will actually happen behind the scene is this transaction or an RPC call gets intercepted, and it checks that okay, this is the API key and these are the contracts registered, and basically it knows that okay, this is meant to be a meta transaction. So once it like gathers all this information, it will make a call to the relay infrastructure, which we just showcase or like talk the features about. So this relay infra knows that okay, this is an API call which I need to process, and and this is the signature, and these are the other details about like okay, which contract to call, which method to call. And once I like gather this as all of these information, the job of relay or relay infra is to like give back the transaction hash, so that the DApp owners or the users can track it like okay, this is how my transaction got processed. So I think we can like jump on to the demo. So I have created a very simple DApp which uses the contract which I have like shown here. So basically what this contract will do is like it just has like two state variables. One is like string code, and another is the address owner, where it's sort of like capturing a flag or like setting a code to a smart contract, but it can be like pretty much any state on any contract that as a user you can like write to, and whoever like writes this code becomes the owner of that code. So this is to actually showcase that okay, what because the relay sent the transaction, but the user has to become the owner of the code, right? So this is the concept, and this is a very simple contract which is deployed on the Moon River network, and it's as easy as like working on any other Ethereum chain. So I just like deployed a couple of contracts from Remix here. I just need to like change my chain, so it just shows up this network and everything is like super smooth. So let me just quickly go to and like spin up this. So here I have already set this code, which shows like the future is multi-chain, and it is set by this user, which is my address here. So now let's go to an account which doesn't have any mover with them, and they want to basically like perform a write operation on the blockchain. In this case, it's a very simple contract, but you can pretty much write any complex logic in your contract and make it gasless. So this is the idea. Let's just try to set like a particular quote on the contract. So these are like different initialization steps where it actually shows you that okay, this is the transaction that this is how like it is collecting your artifacts from the dashboard that you have registered with. Now let's say this is the code that I want to set on this contract. And as a user, when I interact with this transaction, I do not need to like pay for the gas fees. It will just show up to like sign a message on my MetaMask. So usually this is a bit quicker. I might be facing some issue with the internet. Yeah, so here, there it is. This is the step that we talked about, like making a custom signature for a user. And Kevin, this is the EIP 712 signature, that which is like different from the random hacks. So you can have like more
Totally.
control over this here. And once I sign this request, I didn't have any mover, and I didn't have to go through the process of like setting up the gas price myself, and also like gathering these native tokens. Maybe let's say I have mover stake somewhere else, and I don't want to like pull it out, or even on Ethereum, let's say if I'm structurally long on ETH and I don't want to like spend it away for the gas, then these are like very good use cases to offer to your user. And as I send this transaction, I get this result where just a moment. Yeah, so it says like this transaction has been processed. So Relay Infra has responded with this request. So this is how like it looks like. It's a native meta transaction, and as a DApp owner, you just need to process this, and you can actually verify that okay, I processed this transaction and sponsored it on behalf of the user. So now we have if you want to go to the block explorer and analyze this transaction. So it says successful, and here my address is different, which is like 0x61. I didn't need to spend any mover, and like all the magic happens within the infra. And this is the contract that I wanted to call. But if you notice, this from address is different. So this is actually a relayer's address, which paid on gas on your behalf. And here also, if you notice, the code is updated. So now I am the owner of the code. So this means this can be like a complex thing where I wanted to claim the NFT, like the whole the first thing that we discussed in the beginning of this workshop, right? Like I need to, like, let's say, claim some airdrops, or I want some NFT in my wallet. So this is actually like makes you the ownership of that wallet, like without paying for the gas fees to like claim that NFT. So a lot of interesting use cases can open up, and with the added benefits of the whole Moonriver ecosystem on Kusama, you can do plenty of things like with the different hackathon use cases, and we are very happy to support you, like whatever you would like to build on like Moonriver and Bioeconomy. So this was like this one quick demo on like how a meta transaction can be done, and these are like basically the code changes on your side. So this is the third step essentially, where we talk like how to integrate by economy. So here you can just like get the signature and process it like this, and it becomes like even simpler for the EIP 2771 case, where you can't even tell the difference, where if I'm like interacting with a regular provider, or is it a meta transaction. So as a user or as a developer, I'm just calling this method, which is like set code on my contract. So you are just like calling this method, but behind the hood, since we have imported this SDK, by economy SDK, it knows everything. So quickly moving on, uh, these are like the differences in terms of like the base contracts that you need to inherit to for each approach for gasless on Moonriver. And there's another interesting case which is called forward. It allows you to pay the gas fees in the stable coins of your choice, like whichever is supported, or you may request us to like add like whitelist more stable coins to pay the gas fees with. So these becomes like essentially the fee tokens, where like sometimes the gas fees is high, and you don't want to sponsor the transaction for a user, but you want to give them an option to pay for the gas in any other tokens. So this is how it like works like. And if you have any questions, like feel free to hop on Discord chat or on Telegram to like sort of like gather more information on this. But basically the idea is to get the token price, we are using chainlink feeds, and then that execution gas gets converted into x amount of token payable, instead of paying, let's say, y amount of mover. So this is the idea and the whole contract call. And these contracts are open source as well, so you can like find them in the same repository under ERC20 forwarder. And yeah, moving on, another is like we also talked about like interoperability and the complexity of bridges. To in order to solve this problem, we have actually created Hyphen, which is instant like cross chain liquidity transfer between like layer 1 to layer 2, or between like different other layer 2. So you can practically implement like this on like various parachains on like different like moving the liquidity in, let's say, USDC, USDT, DAI, WETH, and you can give the seamless experience to your user for them to like quickly like hop in and hop out of any another chain. This is just how the UI looks like for Hyphen, and these
And
are like some of.
is it right to think of the Hyphen bridge as sort of like kind of like a pooled bridge, in the sense that the expensive cross-chain transfers are only happening occasionally, instead of every time somebody wants to transfer a little bit of a token. It's a lot more cost effective to do so with Hyphen, right?
Yeah. So it's about like when to give you some stats, if you move from like Polygon back to Ethereum, let's say you want to move back USDC, it is about 50% cheaper than using the native bridge. And we manage this by like, maintaining the liquidity pools on both chains. So when you move a token from here, your transaction is listened by the executors, who will later become the also the nodes who are running on like our protocol, and then they will execute this transaction on another chain. So this is how like it gets like a lot cheaper, and you're just like paying for the liquidity provider fees. Yeah, to move on, like these are like some of the case studies where like how we have helped like a lot of different apps and on like across many different mainnets to sort of like improve their user onboarding, and sort of see like how the more users are coming up on that platform, and how like more delightful the experience gets on their DApp actions. So one is about like perpetual protocol, one is on idle finance, and then there are like a lot of clients and the testimonials from people. And we are looking forward to like support as many dapps and like plenty of interesting use cases on Moonriver and later on like Moonbeam ecosystem. Cool. I think I'm almost done, and we have like 5 minutes left. So maybe we can check the questions from chat, Kevin. I think I'm almost
Absolutely.
done. These are
Yeah.
the
Yeah.
resources. Yeah. Sorry to interrupt you. I just wanted to say that like these are the resources, and this PPT is shared with everyone, so you can actually like follow this, or feel free to reach out to us or Kathy, Kevin, anyone, and we'll definitely help you with the integrations.
I'll be sure to post the link to the presentation, a view only link at the end. I'm amazed by the flexibility that's built into Biconomy. I mean, there's no like one way, rigid way that you have to do it. You can really do anything. It's incredibly flexible. I think that's so exciting. Um, and yeah, the demo was amazing. And as you see, it's not that hard to integrate this into your app. It's quite easy. And there's lots of sample code, right? There's lots of like easy ways to get started doing this. I guess we do have a couple questions, but I guess I'll kick it off with one, and that's you know how's your experience building with Moonbeam and Moonriver? I know you touched on a little bit during the presentation.
Yeah.
Um,
Yeah, so like I said before, when I was mentioning about like deploying the contract, so it is super easy to work off sort of like all of these familiar tools, and there is no like other chain like or a layer two which like gives you these benefits, and also the added benefits of a multi-chain ecosystem like Polkadot and Kusama. So this is what I find interesting, and like a lot of more interesting integration can come into the picture when you like sort of integrating with another chains on the whole Polkadot relay chain, right? So yeah, it's been like super smooth and super interesting for me.
Amazing. And it's so cool. If somebody's a first time user, right, to Moonriver, they've never added the network to their MetaMask, right? You can actually interact with the dApp on Moonriver, and your MetaMask has never been connected to Moonriver. That's so cool. You sign a message, and Biconomy takes care of figuring out the right network that you should be on, and taking care of adjusting the signature accordingly.
Yeah.
So cool. And what's next on your roadmap for Biconomy? Is there anything that you can share?
Yeah, for sure. So we are definitely like adding more and more chains. So we are working on like supporting more chain integrations. The next coming up would be like Avalanche mainnet, Arbitrum mainnet, Optimism as well. So we are sort of like supporting like all the different chains in this whole like multi-chain vision, and we are also the work on a path to progressive decentralization, where we will have like more community participation, and the protocol will be open to like participate for everyone, and like build interesting use cases or things on top of Biconomy. So this is the roadmap in coming months, and a lot of work on the cross-chain side as well. Like I mentioned, like cross-chain liquidity transfer, cross-chain contract to contract calls. So a lot of interesting things are happening in the coming months.
Absolutely. One question here, I'll take it. It's kind of a Moonbeam question. Do you know if Moonbeam will avoid bridges? Is the question. No, we love bridges. Moonbeam is a huge fan of bridges. We have AnySwap that is available, and we have Meter Passport. And I'm not endorsing a particular bridge, but Moonbeam has always taken the approach that we didn't want to build kind of a state-sponsored bridge, saying that this is the only official bridge. No, there are many options. There are many solutions that you can use. So that was that. In terms of gas wars, I mean, I think, correct me if I'm wrong, Chirag, but I think, bioeconomy can help to alleviate or, it can kind of reduce the impacts of like a gas war. It can kind of help alleviate that, right?
Yeah. So we are like working with like several IDO platforms where like or even like when you talk about like fair launching of NFTs, what are the solutions that can be provided in terms of, let's say, creating an SDK or providing some helpers to sort of like whitelist these users. How do I know the Discord activity and already know that okay, these will be the users who will be actually able to mint an NFT. So this just giving an example to sort of like having a fair minting process to avoid the gas force. And even in terms of like you can once you have like given your signature, you can like batch these transactions or to be performed at like a later time. So these are like some of the ideas to avoid these kind of gas wars. And also we are supporting like several platforms when they do an IDO. So at the time, like you have like thousands of requests hitting per second to like process the meta transactions. So we have like scaled up infrastructure for this as well to handle these requests.
Amazing. I think we're running out of time. Chirag, I just want to say thank you so much for your time today. This was an incredible presentation and demo. Really excited about Bioeconomy and the integrations that are available right now, live today. You can go and start building with Bioeconomy today on Moon River, which is so exciting.
Yep.